Hello everyone. As discussed in the earlier videos, we were discussing about load flow problems. So the load flow problems is to find the steady state solution of a power system. The main output of this load flow solution would be finding magnitude and phase angles of the load bus voltages, reactive powers at generator buses, real and reactive power flow in transmission line. If you want to increase load, so whether is it possible or not. So all these things are possible because of the digital computers and latest programs. As the power system has number of so many thousands of buses, so a digital computer can easily calculate the variables like voltages, angles, active reactive power for n number of buses using some load flow solution. So as it gives a number of nonlinear algebraic equation, finding out the solution using optimization techniques, solution for this n non-linear algebraic equation is nothing but a load flow solution. So as discussed in the last videos, Gauss method, Gauss-Seidel method are two methods through which we can find load flow solution, and Newton-Raphson method is one of the advanced method than the Gauss or Gauss-Seidel method. So as the power is injected from the generated bus and load taps power from the buses, we have wire generator buses also in the power system. So we need to supply the surplus power through available buses to the place where the power is required via transmission system. There are generally three type of buses in the system. One is PQ buses, where P and Q are known and V and delta, that is magnitude, voltage magnitude and angle, are unknown. Then there are PV buses, or we call generator buses, where voltage and active power are known and reactive power and voltage angles are unknown. And some special bus like slack bus, or sometimes we call it swing bus, where we take it as a reference bus, voltage 1 per unit and delta would be 0 degrees. So using Gauss method and Gauss-Seidel method, if you solve the convergence problem, it takes many iterations, whereas the Newton-Raphson method will converge in very few iterations and it will give load flow solution. Newton-Raphson method is a powerful method of solving nonlinear algebraic equations. It works faster and sure to converge in most cases as compared to Gauss-Seidel method. It is a practical method of load flow solution of large power system networks. The only drawback is it requires large requirement of computational memory. As today's developing world, the large computational memories are possible at cheaper rates, so it would not be a real drawback these days. So converge can be considerably speeded up by performing the first iteration through Gauss-Seidel method and using the values so obtained starting the Newton-Raphson iteration. So here we need to assume the flat voltage profile for all nodal voltages except the slack bus. Set a suitable value of convergence criteria. Set iteration count k equal to 0. Set bus count I equal to 1. Check for slack bus. If yes, go to step number 10. Otherwise, go to next step. Calculate the real powers and reactive powers. Evaluate change in active power. Check for a generator bus. If it is a generator bus, then compare reactive power with the limits. If exceeds the limit, fix the reactive power generation to the corresponding limit and treat the bus as a load bus for that iteration. and go to the next step. If limits are not violated, evaluate the voltage residue and go to step number 10. Evaluate change in reactive power. Advance the bus count by 1 and check if all the buses have been counted. If not, repeat. So we need to calculate for all the buses. So go to step 5. Determine the largest absolute value of the residue. If the largest of the absolute value of the residues is less than epsilon, go to step number 20. Evaluate the elements of the Jacobian. Calculate the voltage increments. Calculate the new bus voltages. Check for generator bus. If yes, go to next step. Otherwise, go to step number 18. If the bus in the consideration is a generator bus, update the real and imaginary parts of the voltages with a phase angle. If bus is a load bus, check for the voltage limits. If it violates the voltage magnitude limits, fix the magnitude to the corresponding limit and keep the phase angle same as in this iteration. If the limit is not violated, go to next step. Advance the iteration count k equal to k plus 1 and go to step 4. Evaluate the bus and line powers and print the result. So this would be the Newton-Raphson method, where we need to assume all the buses are PQ buses, and you have so many nonlinear algebraic equation. So we have vectors of residues, functions between voltage and angle. So we will be having equation with respect to active powers. Similarly, functions of voltage and angle would be in terms of reactive power. Then we need to find the vector of corrections delta x corresponding to delta v and delta delta. Here we need to find number of Jacobian elements, that is dou p by dou m, similarly dou p by dou vm, similarly dou q by dou delta, dou q by dou v. So these are all the various Jacobian elements we need to find to compute this Newton-Raphson method. Here Jacobian matrix would be a sparse matrix if admittance matrix is a sparse matrix. So finally we will be getting a mathematical Jacobian equation in terms of delta p's and delta q's with respect to Jacobian matrix multiplied by the delta and delta v by v, so on. So here the Jacobians are like dou p by dou delta, dou p by dou v, dou q by dou delta and dou q by dou v. So here what exactly we are doing, we are assuming the slack bus 1 per unit and the angle delta equal to 0 to fix the slack bus. Then we are assuming V and delta at all PQ buses and delta at all PV buses. We are comparing delta PI for PV and PQ buses, delta QI for all PQ buses, and we are calculating the active and reactive power P1 Q1 for bus 1 or slack bus. If the convergence criteria is satisfied, or if it is not satisfied, we are finding out the elements of the Jacobian matrix. So we are solving it corresponding to voltage angles and the magnitude. So we are updating the voltage angles and magnitudes by adding the corresponding changes to the previous values. So this is the method. So in this method it is observed that Newton-Raphson method convergence in very few iterations, maybe 4 to 5 iterations, whereas the Gauss-Seidel method for given power system would be taking more number of iterations. So comparing with Gauss and Gauss-Seidel method, Newton-Raphson method is considered as an advanced method and extensively used in power system load flow analysis. Thank you for listening.